No? Better? Cool. So good morning and welcome to a session about Interop. I'm sorry it's so early. It wasn't my idea. It was Michael's idea. You can blame him. This session will be probably like an hour and 15 minutes, and at the end you'll have some time to ask questions. We'll be talking primarily about interop between managed and native code. But before we start, let me introduce myself. My name is Sonja Keserovic, and I'm program manager in Common Language Runtime team. I joined CLR team almost 4 years ago, and I started working on Interop as soon as I started there. That's my only team that I worked in Microsoft. And Interop is the only area I worked with in CLR. So pretty much the only thing I can talk with you about is Interop. So make sure you have lots of questions for me afterwards. So let me just first, before we go into material in this lesson, set your expectations correctly. I got sometimes feedback after these lessons that people wanted more details about how do I do X, Y, Z, what's the best way to use tools, how do I debug common interop problems and things of that nature. Unfortunately, I have to warn you in advance that this lesson will be talking about types of interop that exist currently and how do you pick the type that's best for your situation. So we will be talking mostly about how do you make correct design decisions when you are designing managed type libraries that use interop in one direction or another. So after you complete this lesson, you will know, hopefully, how to make decisions and why behind those decisions, but not necessarily how to implement them once you made these decisions. In my defense, I will give you lots of pointers to resources. You can find answers on those questions. But please, I would really like you to understand that how much important it is to know why before any type of interop decision. Because there's so many things that can go wrong after you make a wrong decision. And your job gets really, really a lot more complicated than it needs to be if you just make a correct interop decisions in the beginning while you're still designing your product. So since there are two directions of interop, this lesson will have two parts. One part we'll be talking about, and which is the first part we'll talk about now, is once you are writing your managed library, how do you expose this library to native clients? Maybe you have native clients. The second part of this lesson will be the opposite direction, which is how do you use existing native APIs from your managed library. At the end, we'll have one part which is about both of these directions, like performance, for example. And at the end, you will be able to ask some questions. So let's start. There are two, basically when you are starting writing brand new managed library, using all those great design guidelines that Brad and other people were telling you about, but then you find yourself in a situation when you need to expose this brand new API that you just designed to native clients. And you ask, the question that you need to ask yourself is, how do I do this the best way? And so there are a couple of answers you can come up with depending on your situation. So the first one, that's probably most common situation, is that you can decide to expose your managed APIs as COM APIs. So native clients who know how to use COM can just go and use your APIs as they are good old COM APIs. Second option, if that's possible, you can decide based on your clients, if they are C++ clients, to recompile them using new C++ compiler. What's happening when you recompile C++ clients with new compiler is that they, from that moment on, can start using managed APIs directly. So let's explore these two options in a little bit more details. The first option is exposing managed APIs as COM APIs. This is this is relatively easy to do. I won't say very easy, but relatively easy to do. CLR has facilities that will make this process for you relatively painless. So what will happen when you have a managed API, managed class you want to expose to COM client? Well, if you go and check, maybe if you generate type library from your assembly, what you will see is that all your public methods are automatically already exposed to COM. So you basically don't need to do almost anything. As soon as you have a public class that has public methods, that will be visible to COM clients. You might ask yourself if you know how COM works. Well, I didn't implement unknown, that's requirement by COM rules. Well, that's one of the things that CLR is doing for you. So CLR interop layer will, for every public managed class, implement iDispatch, unknown, and a whole bunch of other very well-known COM interfaces. We will give you tools and APIs to register your classes, because as you know, COM requires objects to be registered. So we'll give you ability to do that. And we will give you even something more than usually COM is giving to you. We'll give you ability to register these classes side by side, which means that you can have multiple versions of your managed classes registered at the same time in the registry, and your COM clients can pick which version they want. This wasn't possible with old-style COM objects. The other thing that you will notice that you never need to take care of reference counting, for example, which is requirement by COM. Again, CLR interop layer will do that for you. So as soon as your COM client does not reference your class anymore, we will notice that and make sure that garbage collector knows that your object is now available for collection. But there is a big but at the end of all these nice things that CLR interop is giving to you. There's always a but, which is if you don't design your classes to be used from COM, they probably won't be very usable to your COM clients. Good examples are classes that don't have default constructor. You maybe know that co-create instance API that's used for creating classes from COM does not have any ability for you to pass any parameters. So if your class is visible to COM but can't be created, obviously it won't be very usable to COM clients. Also, static methods are not visible to COM clients at all. So if you have a significant portion of your functionality available in static methods, that won't be usable to COM clients. And in the end, the versioning rule between managed world and COM world are very, very different. So you have to know both of these to make sure that something can version correctly from both perspectives. So the whole point of this is that, yes, exposing things to COM is easy because you don't need to take care of any COM plumbing at all. Sorry. But what needs to happen is that you have to design your classes to be used by COM. So just to illustrate my point and how disastrous can it be to just blindly expose your public classes to COM clients without really considering any of these design problems I was talking about. These are some examples from .NET Framework, BCL base class library. So we did all these mistakes I'm telling you about. And that's how we basically build our experience, so I can come here now and talk to you about all these things. The first example is system.math class. It's visible to COM clients, but it contains only static methods. So COM clients can't do anything with it, even though it's visible. System collections bit array doesn't have a default constructor. Again, COM clients can't take advantage of this class unless somebody else passes them instance so they can call methods on it. And probably the worst nightmare we ever had is the nightmare of versioning. There is something, the easiest way, let's say, to expose managed classes to COM is use something that's called auto-dual class interface. What that means basically is that you put this attribute on your public class, and what Interop layer does for you is, because COM can talk only in terms of interfaces, not particular objects, so we need to create interface for this class. So what we'll do? Well, we'll take all the public methods on your class, and not only that, but all the public methods on all of your base classes, make huge interface, and expose that to COM as your class interface. So you can think, oh, that's really cool, I just write my class, I don't need to implement any interfaces, great, COM clients, just go and start using me. Well, what's going on in the next version? Like if you go and check a system.type type, that type was exposed with this huge class interface in the version 1 of runtime. Well, what happened when we started working on version 2? Well, people starting adding methods on this type. Obviously, that's what we do in next version, add more stuff. Well, guess what? As soon as you start adding methods on this class interface that COM Interop layer generates for you starts changing. I have a whole bunch of methods here, there, without any ordering or anything. It's just completely different in a second version. Well, what's going on with your COM clients if you try to expose them this without any changes? Well, they get broken because, interfaces are contract in COM. You can't change them from version to version. So we had to do something about it. We can't just go and ship version 2 and break everybody who was depending on COM interfaces. I mean, we could, but not that we want to. So we had to come up with this new interface. We have to kind of completely reverse engineer the whole interface that was exposed in version 1. And if you go to base class library today with the Whitby builds, you will find this underscore type interface in system, in Interop services namespace. And it contains all the methods in precisely the same order that was exposed in version 1. And system.type now implements this interface. And it had to be name underscore.type because that was the name that Interop layer generated in the version 1. That was our naming convention for generating these class interfaces. So you can imagine Brad's surprise when we started checking in these interfaces, because this type wasn't the only one, unfortunately. So we have like 10, 15, 20 interfaces that have naming like underscore something checked in a system namespaces. And Brad comes and starts screaming, like, what are you guys doing? What kind of naming convention is this? Who told you to check this thing in? And so on and so we had a big fight with Brad. But basically, we had to check them in to preserve backward compatibility. So compromise was that we'll move them instead of system namespaces to Interop services namespace. And if you go to that namespace, you will see that we really don't follow any of the naming conventions and stuff like that. We kind of get some pardon in that namespace. But my point is really you have to think about these things in advance before you make your design decisions. And this caused us lots of pain, and lots of work went into these things to preserve this backward compatibility, just because we didn't think in advance. So learn from our mistakes, and make sure you don't do things like this. So what are the best practices then? So obviously, you have to design in advance if that scenario you care about. If you know you'll have COM clients and you want to expose your functionality to them, you have to design in advance. And after lots of thinking and trying different things, the recommendations we came up with was that you should really separate COM-friendly APIs from managed-only APIs. It is extremely difficult to follow both rules for designing something that's managed-friendly on one side and COM-friendly on another side, and have the same API that has both friendliness. So what we're suggesting people is to start designing their managed APIs, following all the design guidelines, and have their set of APIs designed like that. Make this COM invisible. Their attribute you can use COM visible through false to make your classes COM invisible. Then design a separate set of APIs that is for COM clients only, and you follow all the design guidelines for these APIs. Obviously, these classes can internally just call into your managed only classes and just forward calls back and forth. For COM-friendly, once you start designing COM-friendly APIs, there are certain rules you need to follow. Obviously, you have to have default constructor. You can't have any static methods. And to avoid this versioning nightmare, you have to explicitly implement interfaces. So you basically have to do the same thing that COM world is doing. You have to put your contract in interfaces, and you can't change them from version to version. In next version, if something new gets added to your managed APIs, you have to add new interfaces to expose this to new COM clients. So you can't allow breaking your COM clients by changing interfaces. Yes, there is a question. So question was, this seems lots of work from designing perspective, implementing, testing. So what should teams do if they're not willing to pay this price? Should they just block COM clients? So it depends from your scenario. Let's say that you're not quite sure if COM clients are your target or not. And if you see on the other side that the tax to pay for them is too high, you just make everything COM invisible and say, sorry, I'm not supporting COM clients. Or you can go, approach somewhere in the middle which is like, well, I won't expose everything I have to COM clients, but just this basic little functionality, I'll just expose 2-3 classes. That is not too bad. So you can decide to kind of split functionality that way. And the third way that we'll be talking next is really preferred way, which is if your COM clients are C++ clients, just recompile them with new C++ compiler. And I'm not sure if you can see this, but this is an example of how you actually go and design these COM-friendly APIs. So there are a whole bunch of attributes, if you can see, that you need to do. So the first thing up there is interface. So this interface, you need to, as I said, explicitly implement interfaces. So you define your interface, add all the methods you want to expose to COM clients, and then decorate with certain attributes. So make it COM visible, obviously. Give it explicit GUID, so you can use the same GUID in the same version. Unless you put GUID, we will generate one automatically for you. So it's better if you just, explicitly set a GUID yourself. And then on the bottom, there is a definition of the class that implements this interface. And this class also has a couple of attributes. Also, it has a GUID explicitly set. As I said, if you don't do this, we'll generate one automatically for you. But it's better for you just to put the fixed one for yourself. And then the most importantly, it says class interface is class interface type none, which means please COM Interop, don't generate any of those magical class interfaces for me. I'm implementing all interfaces I care about. This is extremely important. This is the most important thing you need to do when exposing COM classes to COM. If you forget everything else, please just remember this one, class interface none. And you can say which one of your interfaces, if there are more than one, which you want to be default for COM. And that's it. So as I said, advantages of this approach, it's, you don't need to take care of COM plumbing and stuff. We'll do that for you. We'll just make them visible to COM clients. They'll be able to reference count them, use them in all the same ways they know to use COM server. But as you could see, it's really hard to maintain two sets of APIs following all these rules. So then, what are the alternatives? Well, if your clients are not C++ clients, that's the only choice you have. But if your clients are C++ clients, there is one approach we really recommend people to try and explore, which is recompiling C++ clients with new C++ compiler and use something we call C++ Interop. The thing that we were talking about before is called COM Interop, so just terminology. And C++ Interop is also known as IJW. Does anybody know what IJW stands for? It just works. And that's the beauty of this approach. Well, it doesn't work all the time, but we're working on it. We're working on it. It's getting better every day. And it's really magical. What's going on is that you have your C++ client, which is all native. You didn't change any code. You just threw this magical CLR switch when you were compiling it with new compiler. And suddenly, you can start directly in this code, write calls to managed APIs. So, did anybody have experience with using C++ and Interop? No? So when I did that first time, it was really like, wow, I could not believe it. It's really, you just write calls to managed APIs from your C++ clients, and everything just works, mostly. So that is really an approach we are recommending people to do. If it's possible, if C++ clients can be recompiled, go recompile them. You don't need to worry about any of these COM rules anymore. You can just go and create your managed objects directly. Everything that's accessible to managed clients is now accessible to these native clients. There are no wrappers. There's no special APIs you need to define, nothing. Problem is that once you start doing this, there are certain rules you have to follow. And if you go and read the C++ documentation, you'll be able to see all these rules. Like, oh, I can keep a pointer from native class to managed class, but I have to do X, Y, Z. I can keep a pointer from managed class to native class, but I have blah, blah, blah. So there are certain rules you have to be aware of when you're kind of mixing managed and native code this way. So if you have a C++ client and recompiling is a really option, we would really recommend people to first check latest guidelines and resources. As I said, IJW and C++ Interop are still technology that's evolving, so there are things that we know are still not working, and we are working on improving them. So, and as we are going on, we are updating our guidelines. So please make sure to check the latest guidelines if you decide you want to go this option, just to make sure you are aware of all the issues and workarounds for them, so you kind of make decisions based on all information you can get. Also, if your clients are really big native applications, it doesn't mean that you need suddenly to recompile everything in this huge application. You just, if you know that you will be calling only from certain modules into managed APIs, well, you can just recompile those modules. You don't need to recompile the whole application. The only kind of issue that I want to highlight here to make sure you know about this is that C++ Interop is still not very good for dealing with subdomains. If you maybe heard about subdomains, if people were talking about that in the previous lessons, maybe you know that all managed code is executing in certain subdomains. So there's no managed code that executes outside of subdomain. So it's usually a default subdomain if you have only one, but maybe your application is creating multiple subdomains. If it's ASP.NET application, it will have multiple subdomains. So you just need to be aware that currently C++ Interop is not dealing very well with subdomains because native code is executing outside of any subdomain. So once you have to make transition from native code to managed code, this transition needs to go into certain subdomain. Well, how do you decide in which subdomain is supposed to go? That's a question. So, currently there are some rules that C++ follows to go into subdomain. It will go in the last subdomain that where the thread was, and if thread never went into managed code before, it will go to default subdomain. But you need to be aware of these rules. Maybe that's not something you want. Maybe you want to go some other subdomain. And currently, there is no good way to specify directly in which subdomain you want to go. So if you want to, if you know this will be your situation, please contact me, and I will find you latest resources and guidelines. And C++ team is also very busy adding new features to C++ language. So you will be able to specify relatively easily in which subdomain your code needs to go. Okay? So as I said, you should be aware if this is option that looks interesting for you, just make sure you know what are advantages and disadvantages. As you could see, you as a managed library designer, if your clients will be native C++ clients, that's great. You don't need to worry about anything. You know that we'll just be able to use your APIs no matter what you do. And you don't need to worry about, oh, if I use statics, oh, will that be accessible? Oh, if I use generics, will that be accessible? No matter what you do, it will be accessible from managed C++. Disadvantage is that this type of interop technology is not as magical as CLR interop. So you have to really know what you're doing. You have to know how I keep pointer from this to that. It's nothing. There's no magic there. You really have to know how all these things work. And you have to have a deep understanding of rules on native side and rules on managed side so you can follow them correctly. So to finish with this first part, when you're exposing managed APIs and you know that you'll have a native clients, first option you should think about is recompiling those clients with new C++ compiler if that's possible. If that is not possible, think about exposing COM interfaces. And when you are in this situation, also think hard if you need to expose everything or just part of your functionality will be good enough, because that will save you lots of time and maintenance and testing and so on. Okay? So you are not too sleepy. I know it's really early. I have exercise for you. So imagine for a moment that you are a big WinFS architect, okay? And as you know, WinFS, that's a new managed APIs will be exposed from WinFS. And then Office team comes along, asks you to use your functionality. Then you're really happy. Like Office is a big team. If they take dependency on my features, well, that's really cool. So they ask you to use your APIs. You can't be happier. But then Office team tells you, well, but we are not using managed code. Office is native. What would you do? Oh, come on. Somebody, you're all Microsoft people. You shouldn't be shy. Okay, so core Office is C. So it means no recompiling, correct? I think C++ compiler can compile C too. But do you think Office would be willing to do that? Switching compilers for whole Office, not an option? So how would you, like you're an architect, now you're in a hot spot. How would you deal with this situation? Yes? So one option is exposing COM wrappers for Office to use it. Okay, Office can use COM APIs. They would be happy about that. Would you be happy about that? Would you, as an NFS architect, sign up for writing a separate layer of COM APIs for Office?
Well, it wouldn't be just for Office purpose, but it sounds kind of reasonable to have it there.
Okay, so that's one advantage. It wouldn't be only for Office, for everybody else could use them. Okay. Any other options? No? How about suggesting Office to, recompile only parts of Office that will use WinFS? Do you think they'd be willing to do so? Maybe?
Or you could have them write their own C++ interface that talks directly to unmanaged code, and then their native code can talk to this new layer that they built.
Yeah, great. So there is a solution saying that, well, Office team, if they're really interested, they could write their own C++ wrappers using managed C++ to access, on one side, WinFS APIs, and the other side just expose maybe C APIs to the rest of the Office. Yeah, that's one option. So I can't claim I know the answer on this question. I just want you to kind of think of different solutions that exist today and weigh pros and cons before you make any decision. That's the whole point. Just to know all the options, advantages, disadvantages, and just based on this knowledge, you make your decision. It's not because your buddy there in Office said, IJW sucks, or COM Interop is really slow, or something like that. So you just kind of need to know all these facts before you make your decision. Question?
I think that there is a big design difference between the .NET and COM that I think need to be mentioned. The COM is more of a big component. You use a big chunk of code. It's a big service. .NET you use like smaller classes. It's more of like you design for using them. You can't expose this set of classes to the COM wall to be used. You can't use something called point, for example, that has an X and Y and move and roll.
Mm-hmm.
So I think if you want to do this in the Interop layers, thinking this
Yeah.
people, you have to kind of like, you have to use like a bigger chunk.
Okay.
It has to be designed.
Okay.
It has to be designed to be used.
Yeah. So to just repeat the question, question was, well, are there any other design considerations that need to be taken into account? Because COM usually exposes like bigger chunks of functionality than, let's say, framework APIs, managed APIs, where you can have a point that has only like 2 values, which typically you wouldn't use maybe in COM. And how do you go about, redesigning your really managed API to get into these COM design guidelines? And yes, the question, that's a valid thing to think about. Maybe your APIs, managed APIs, are too granular for a COM client, especially if you know, oh, there will be perf impact of transitioning between managed and COM. Do I really want to expose getters and setters that only just operate on one value and change a value or give a value back? Would you expose that as a COM API? Well, maybe not, depends. If that's something that's called millions of times, that you expect will be called very often, well, you probably don't want to do that way. You probably want to kind of then re-architect your COM APIs to expose the functionality in a little bit more like chunky way, so you don't make so many transitions. That's a valid thing to think about, and we'll be talking about performance considerations a little bit more at the end of this talk. Okay. So the question was what Office did and what WinFS did. Yeah, so we kind of can't recommend people the same thing. We can, based on the things we already saw, recommend, these options and tell you what pros and cons of all of them are, and you have to make your choice because, we can't know as much about your applications and your situation as you know. I know for a certain period of time, WinFS was exposing COM APIs, and they even had a tool that automatically generated them from their managed APIs. But I know that they want to move away from that, encourage everybody to use C++ because they were having huge maintenance costs and having problems keeping these in sync. Yes, to use, yes. As far as I know, Office still didn't make any decision in this regard, so I don't know what they'll do. Okay. So that was the first part, which is, how you expose your managed libraries to native clients if you have any. Let's talk about the other direction. You might not have any native clients for your managed libraries, but maybe you have to call some native libraries from your own libraries because you can't afford to rewrite everything. And Shell is a good example. They're using native components from a Shell, and they're writing parts of Shell in managed code. Part still is native, so they have to interact. Even .NET Framework is written on the top of native APIs. So, .NET Framework APIs, in its implementation, they all call native APIs. So, as I said, you shouldn't be thinking that, well, my new application, my managed library is managed. I should go and rewrite everything to be managed, all the other libraries that I use. Well, it's not really rewrite everything strategy. This Interop technology works very well. So you can just say, well, all these libraries that I have that worked very well before, I'll just continue using them and just make these new managed libraries and expose nice managed interfaces. And that's probably the best thing to do if you are working on a new version of your product. And you say, well, I will expose managed APIs. You start designing your managed APIs, following all the design guidelines you hear here, and then just decide where from your managed library you will use your existing native libraries. That's something we recommend people to do if they have obviously enough time. Sometimes people don't have enough time to go and run the whole new managed library with whole brand set of new APIs. And sometimes people ask, so what I do then? And if you have these time constraints, resources, well, as a temporarily step, hopefully in some version after that you will do right thing, but as a middle thing before you can really spend time working on a real managed APIs, you can write the thin wrappers around your native libraries. And if your native libraries are COM libraries, you can use CLR tools to just generate these wrappers for you automatically. And those are called Interop assemblies. We do not recommend people to use that as a permanent strategy for exposing managed APIs because what will happen is that these Interop assemblies will just contain one-to-one mapping between your native APIs and the managed APIs that are generated. So if you had interfaces in your library, there will be corresponding interfaces Interop library. And as you can imagine, when you were designing your COM APIs, you probably didn't follow design guidelines for writing managed APIs. So what it gets generated is not really by any means a good managed API, usually. Yes, there's a question.
While writing the unmanaged API, should we follow the new managed API naming guidelines or should we retain whatever API name that we
So question was, when just wrapping native APIs, what should we do with the naming conventions. Should we use the new naming conventions for managed APIs, or we should just use the same names that exist in the native library? And if you use these automatic tools, if you use type library importer tool to generate interop assembly, you don't have a choice. It just generates the same names as COM library used to have. If you are really writing a layer around your native library, well, it depends. You should, if ideally, what's recommended approach is that you really spend time rethinking your APIs. You should kind of expose a new set of APIs following design guidelines that you hear about here, and just internally call these native APIs. Obviously, naming convention for new APIs will be following managed native conventions. So that's what's recommended approach. And but that requires time for redesigning, because you probably won't have one-to-one mapping anymore. You'll probably redesign, re-architect stuff differently. And if you really have to write one-to-one corresponding APIs, so you kind of know that people who used to use these APIs from native code will be maybe confused if you just suddenly change names. You can keep maybe the same names, but as I said, one-to-one mapping is really something we recommend as a temporary solution until you really work on a real managed APIs. So I don't know. I hope that answers the question. Okay. And also, if your native APIs are not COM APIs, but flat APIs, just static exports from a library, you can expose definitions for these APIs called p-invokes, so people can use those. But again, ideally, you would just go and write a new wrapper around your native API. And for this direction of interop, again, there are a couple of ways you can go. And which interop technology to use from your new managed library depends on what type of native API you have on the other side. There are a couple of types of native APIs. There are DLLs with static entry points, like Win32 APIs. For this, you can use CLR interop, which is called, for this type of interop, is called p-invoke. Or you can, again, use C++ interop. Then the second type of native APIs is COM APIs, like ADO, for example, of Office APIs. For this type of native APIs, you can, again, use CLR interop or C++ interop. And the last type, third type of native APIs you can have are C++ library, like MFC libraries. And for these, you can only use C++ interop. So when you come to the situation like this, so you have unmanaged API, you know what the type is, you want to expose and managed APIs on the top of these APIs. So managed clients can use these more easily. What do? Which technology you should choose? And again, answer is the same as before, depends. And you can think, yeah, well, that's really great advice. Yeah, thank you. But really, it really depends. And I want to really give you tools you can make decision for yourself. That's really important. If you can make decision for yourself based on good information, then that's really ideal. That's what you should do. Nobody can give you really flat answer. Like if somebody comes to you and tells you like, man, like C++ interop, that rules. That's always the better choice. Please don't believe them. There are good situations where to use those. There are not really so good situations. So please make your decision based on information and facts, and not just because somebody else had a good experience with some interop technology. So in order to make this decision, again, to main team, you have to know pros and cons of each one of those. So pros for using CLR interop in this direction is, again, there's lots of magic happening. There's lots of things you get for free. CLR interop, it's really thick layer, so it kind of hides whole bunch of things for you, like data marshalling, for example. you pass a managed string to API, and poof, on the other side, it's B string. So, and again, you get back some com type, and on managed side, oh, you have nice managed type. So that type of magic is happening automatically. So you don't need to take care of data marshalling. Again, object lifetime, you never need to take care of reference counting. If you're using com object, you don't need to do add ref, release, remember, oh, did I leak any objects? Oh my God, CLR interop will do that for you. Even worse, if you ever worked with department transitions or context transitions in interop, that's really scary. Again, CLR interop will just do that for you. Exceptions, error handling, whenever you get an error H result, it will be nice exception on the managed side. So CLR interop will take care of all these things. Also, there are still some mechanisms in place so you can fine tune this magic. So it's not totally magic. You can influence what's going on. You can, for example, manipulate a native memory directly and still stay verifiable, which is nice. But you have to know what you're doing too. But there are disadvantages as well. If you're using flat APIs, for example, you have to write declarations manually. And that's sometimes very difficult, depending on APIs you're calling. And that's probably one of the most frequently asked questions we have is, why the hell I need to write pinbox declarations? Why don't you guys publish declarations for everything? Why don't you write tools that will write declarations for me? And so on. Also, even when we have tools in place, like type library importer to produce interop assemblies, they are not perfect. Why they're not perfect? Well, I want to say, oh, it's not our fault. But the problem is that some COM objects are IDL-based. Once you take IDL and make a type library, some information gets lost in this process. And type library importer takes type libraries, not IDL. So we don't have all the information. So we can't generate you correct interop wrappers. So that's a problem. And also sometimes if you are working in an environment where both the native and managed parts are changing, you have to make sure you're keeping them in sync. So, C++ interop on the other side, it's really magical in a different sense, which is there are no wrappers. You just include header file in your C++ project, and you just call it as you would call it always before. So everything just works. And there's a good thing is that, as soon as I include a header file, even if something is changing in this header file, I'll have compile time checks, so I'll know. And also for some scenarios, it's important. In this case, you have full control over every interop transition you make. So there's no this tick magic layer that hides all these things. Everything's transparent, but then there's these cons. There's no magic in a sense that you have to know all the COM plumbing rules, for example, if you're using COM APIs. So you have to continue using add ref, release, make sure everything is released properly. Not only that, you have to do all the marshalling. So you have to convert from managed types to native types. C++ team developed a good set of templates to do this, but again, you have to know to use them. And as I already mentioned, handling updomain transitions is tricky. And so, especially if you're writing libraries, because your libraries might be used from different updomains, you don't have any control over that, how your clients will create you. Maybe they'll create you in separate updomains, you never know. And this gets tricky. And so in order to handle these types of situations correctly, you have to really know a lot about how these things work. So what are then best practices if you are in this situation? I just want you to remember that both interop technologies work for all the situations you might be in. It just, sometimes people think, oh, C++ interop can't handle maybe this situation, or CLR interop can't. Usually, both the technologies can handle everything. It's just a matter of effort, how much effort you need to put into these things to make them work. And sometimes, work needed for one technology is much bigger than, work needed when using a different technology. So that's the type of thing you need to think about before you pick your interop technology. So if so these are some recommendations we came up with after lots of thinking, experimenting, seeing what people are doing, types of problems they have. We say, well, use CLR interop. If you're using flat APIs that are simple, easy to declare, no problem, no big deal there. And use CLR interop is if you are using limited number of flat APIs. So if you don't need to write like huge files of p-invoke declarations. On the other side, we recommend using C++ interop. Obviously, if C++ is already your language of choice and not C#, this is kind of obvious. But also, if you're calling very complex methods that use types of parameters that are not really easy to represent in managed code, like structures with variable sizes, that's not something that's easy to represent in managed code. And if compile time checks are really crucial for you because both sides are changing. Again, for COM objects, both technologies really work. And we recommend using CLR interop if you're using automation compatible COM APIs. Yes, there's a question. Okay. Okay, so question was how to mark p-invoke methods to make affect scope happy, basically, to have a safe bucket, unsafe bucket, and how do you do about deciding which one goes in which bucket? I'm not quite sure. I'm not sure if you already had affect scope talk or not, or that's today. As far as I can tell, I'm not, so maybe it's a good question to ask also during that presentation. Safe p-invoke methods are basically p-invokes that even somebody calls them, there's nothing they can do, like get a system time maybe, that type of API. So then when the tools are evaluating who is calling this API, they can see, do you take a user input and just pass it to this p-invoke? And if it's safe, then that's probably okay. But if you have a p-invoke that will go and erase a file on your hard drive, that probably shouldn't go in unsafe bucket. And then tools can see, this one is unsafe. And if I go this code path, this user input will go directly to this p-invoke. That's probably something that shouldn't be happening. So I think that's kind of general, but more precise. Maybe FXCOP people can come up with better guidelines there. Okay. And so to finish this one, we recommend using C++ interop if, again, C++ is your language of choice, that's obvious. But if COM APIs are ideal based, because CLR interop then won't generate correct signatures for you. But we also kind of have this caveat that you should use C++ interop only when you are fully aware of all C++ requirements. So if you think that you're maybe not kind of know enough about this and you're not sure that you want to spend time making all your team come up to the speed with C++ rules, well, maybe you can consider still CLR interop. And then if you really decide to go C++ route, these are things that you need to keep in mind. First, as I already mentioned, check latest guidelines and resources. Use new C++ templates, new in VidB, that will make making interop transitions easier. There are a couple of those here. And we recommend people to use them because it's extremely hard to get certain aspects of interop correctly if you're doing it manually in C++. Like if you ever had to do anything with apartment transitions or context transitions, that's extremely hard to do manually. It's probably like 3% on the whole earth know all the rules related to this. And one is in CLR team, one is C++. So please use templates because they promote correct usage. And if you are in any Bay node that will be affected with updomains, there will be more updomains than one, please make sure that you check specifically this topic as well. And I'd also like to mention that one aspect that's interesting we addressed in VidB as well was taking care of native handles. We developed these new classes called safe handle and critical handle for wrapping precious handles. Precious means that you absolutely can't leak these handles. And before VidB, it was really hard to do this because if you go and check, even if you see like 2 lines, well, actually 1 line, like, oh, I call this pinvoke method that gives me back native handle, and I assign it to this managed variable. You think, oh, well, that's safe. But, well, if you go and check an IL for this 1 line of code, you'll see there are multiple lines of IL generated. And as soon as there are multiple lines of IL generated, exception can happen in between any of those. So what can happen is basically that you call this pinvoke, it gives you a handle, but before you actually store a handle in your managed variable, exception happens. Now, even when you have your finally blocks, you don't have a handle assigned to managed variables, so you can't release it. So after that point, your handle is leaked. So if you can't tolerate situations like this, if you can't recycle process, we recommend people strongly to use safe handle. Safe handle will wrap a handle in a safe way, so we guarantee it won't leak. There are also some other guarantees associated with these, like security. We will reference count them, so there won't be any security problems related with reusing handles. Maybe you've heard about that. But we recommend you to not use these because they're really heavyweight. There's lots of guarantees they are giving to you. So if you don't need these guarantees, don't use safe handles. But there is a link to the safe handle spec. You can check if you know that you'll be in a similar situation. Okay. So just to summarize, as I said a couple of times, maybe one too many, pick appropriate technology for your scenario. Check the latest guidelines and resources, and there will be a slide with resources. And maybe it really sounds silly, but please make sure before you call some native APIs that that there's no equivalent in managed code. You would be surprised how many of these we found in the managed code across the company. We are writing a tool that would go over managed source code, check all the native pinvoke calls you are making, and make sure that you're really making calls to APIs that do not exist in framework. And as I've heard last time, there's like more than half of all the pinvokes are actually pinvokes that could be avoided altogether. So please don't make this mistake. And maybe one other short exercise in this direction, if you were Avalon team, and you need to use some very, very complicated native flat API, what would you do? And as you probably know that Avalon is written in C# too. Any takes? Oh, sorry? Pinvoke to this. Okay, so that's a valid option. Okay, so there's like the option that it's really complicated. Should I use a, just C++ wrapper to get call? Yeah, that's a valid option. Would you kind of ask some other question before you make decision? Would you kind of try to kind of probe situation a little bit more? Like, if it's only one API, what would you do? Pinvoke, okay. Probably doesn't make sense to introduce yet another, source file. But if it's, there'll be hundreds, then I guess that affects your decision as well. Or do you have anybody in your team that knows C++? No, maybe that's also a thing to take into account. Or maybe there's intern coming and you'll give him to write p invokes. That's okay. So those are just like things you need to think about when you're designing these things. There are two options. You really just kind of need to pick which one is really working for you. Yes?
Not related there. If you're using interop, is there a guarantee at what time the structure of your managed object is going to get run? Because if you're running a regular object, you know that this structure
Yeah.
get executed. If you're using interop, when would that structure?
Yeah. So question was, since in a COM world, you know that COM object will go away as soon as you drop the last reference on it. What is going on when you're using this COM object from a managed code?
Actually, it would be if you're using a managed object that is wrapped.
Okay. Okay. So the other direction. Okay. So
Native world, if you're playing
yeah. So what is going on if you then use a managed object from a COM client? When you're in COM world, what's going on as soon as the last reference is dropped, your object goes away. Well, in this case, if you use COM interop, what will happen is that there is object in between these two. So there's this magic happening in between your COM client and your managed server. And so what COM clients actually see is this object in between. So when a COM object drops the last reference, this object in between will say, so I'm not needed anymore. So what I'll do, I will make this guy I'm referenced to available for collection. So that will what happen. So this guy will then become available for collection. It will not go away immediately as the COM client drops the last reference, but it will wait till the next GC cycle. So that's what's going on. Okay, so yeah. Okay. 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 So question was if you need to p-invoke to a native API that as parameters has like huge structures maybe or pointers to huge parts of memory, what should you do? Yeah. Yeah. Okay. So if you declare your p-invoke, so it takes managed parameters like managed structures, like it's huge structures, huge array. You don't need to do anything. Interop layer knows to pin everything and marshal everything correctly. If that's a huge performance overhead, and we just have that on this slide, then you can say, well, I really don't want to, take all these native arrays, make managed arrays from them, and then do some modification and pass this back, and then marshaller takes this array again, marshals it to native memory, so there's lots of work happening there. If you know that, for example, even arrays are huge, you will just access a couple of elements in this array, then you can go route of a manual marshalling. Even when you're using p-invoke, you can do that. You don't need C++ for that. You can use pointer, int pointer type to do this. And if you go and check a marshal class in Interop services, namespace, you will see lots of methods on this class that enable you to actually operate on these pointers and manipulate memory directly. So you can actually, use the same native memory from your p-invoke. You don't need to pin if you use native memory for arrays. So you just keep a pointer to array in native memory, not on a native keep, and just go use arithmetic to figure out which element you need, and then just read that element, and just that element that gets converted to managed type. So it depends on the situation. You don't need typically to do any pinning manually. Yes?
I'm assuming COM class is written in C++ and used from managed client. What are the isolation boundaries? Like in COM C++, there is apartment threading and free threading.
Mm-hmm.
There is some threading and boundary of
Okay.
the apartment. When this moves to the managed, being used from a managed layer, Is it the same thing is being respected, or what is the boundary? It's not just part.
So question was, so is there any, are both sites now managed, or one is still unmanaged, one is managed? Okay.
That is the original one, and I'm assuming new
Okay.
application.
Okay. So if a question was what's going on with apartments, what's the boundary between managed and native? If you have a managed server, if your API library is managed, and if you go and check when it's registered, it has to be registered, you will see it's registered as a free threaded.
What if there is existing object?
So if you are using, and the question is what's going on in the different direction when an object is a COM object and you are calling from a managed client, what's going on if you're using COM interop as a managed client, you won't notice, but COM interop layer will take care that COM interop layer will know in which context or apartment your code is executing currently, and it will make sure transition apartments or contexts if necessary.
But there is a process transition that is text transition first.
So you will first, when you're kind of calling from a managed client, there is again an object in between, and this guy behaves like to be on the border. So you will first, I'm not quite sure in the implementation, probably to native code, and then native part of COM interop will transition and correct contexts or apartment. Okay, so let's quickly just finish with slides, and we can take questions at the end. So for performance, you need to make sure you take this into account, obviously, when you're designing your solutions. And if you didn't already hear in performance lesson, you need to know your performance goals and measure carefully against them. And always, if you can, design this make call worth of transition, because as you can see for pinvoke, it takes 10 machine instructions to make pinvoke transition and around 70 in VidB to make COM interop transition. Plus, on this, you have to add a cost of marshalling. If you use primitive types like integers, there is no cost there. But if you're using strings and they need to be converting from B strings, Unicode, ANSI, there will be a cost there. So you need to know about this too. Also, one of the things that's coming up now, because we are supporting 64-bit platforms, you need to take care about portability. So make sure if you have any native parts using some native libraries from your managed libraries, and you want your libraries to continue working on 64-bit platforms, you need to make sure that native parts exist in 64-bit version as well. And there are some tidbits that you need to take, keep in mind, like if you're using structures to make pinvoke calls maybe, and they are defined as unions, or if they are defined like elements with exact offsets from the beginning of structure, you have to be careful about these offsets. So probably won't be able to make it so it's portable, but unions are fine because offset is 0 for every element, so that's portable. And do not use integers to represent pointers. Use int pointer type. Integers are 32-bit, and they are not very good on 64-bit platform. And if you want to, say, well, you're really like, why are you giving me such advice? Who would ever use integer for a pointer? Well, that's your example. We did it in .NET Framework in version 1. So if you look at Go in the beginning, there's a COM version of this interface, INO variant. And as you see, there's 2 parameters that are pointers. So the second definition is definition from version 1 of .NET Framework. And as you can see, all the pointers are integers. So we had to make a new definition of this interface. Obviously, we can't change existing shipped interface definition. That's a contract. We can't break people. So we had to add yet another interface definition with correct parameter declarations. So please make sure you don't do these types of mistakes. And so just to summarize this whole interop session, as I said 100 times already, please know your options. Do not rewrite everything, but use appropriate interop technology for your specific case. And be careful, obviously, about performance. You probably, if you didn't hear already, will hear today a lot about performance. And there are some tools also for you as a developers you can use. Did you ever heard about managed debugging assistants, MDAs, or CDPs, customer debug probes? Nobody? Well, this is something great. Everybody should know about this. MDAs or CDPs, they're kind of changing names all the time. We ship them in Everett, so they exist today. And what they are actually mechanisms for you to see what's going on inside runtime. Usually when you're writing application, you can't, unless you have obviously runtime sources, but even then you probably don't want to look at those sources anyway. You don't know what's going on. For example, in Interop, people often like take a pinvoke, write a pinvoke declaration, and something's not working. What do you do then? You know, you don't have any choice. So managed debugging assistants, MDAs, are actually enable you to peek inside runtime. Unfortunately, these assistants, we have to implement them, so it's not an extensible mechanism. But there are a whole bunch of them, especially now in VidB, that are, and most of them are Interop related. So what you need to do is only to put a small config file next to your application. And when you start debugging, you will start getting notification if something's going wrong. And there are different types of these, and there are documentations on them. So please, please, if you're doing any type of interop, turn those probes on when you are developing. It's really tremendous help. And besides this, use FXCOP. It's great interop rules there. And sometimes people forget, but you need to turn on mixed mode debugging. So that would be everything for this time. As you could see, CLR Interop and C++ Interop can provide you support for all scenarios you are facing in your job. You don't need to rewrite lots of things. Some of them you should maybe. And you need to pick the best strategy for your particular situation. And at the end, these are some resources. You have them on your deck, so you don't need to try to write them here. But the first thing I recommend people always to do is to check this white paper. It's not very long, I promise, but it kind of summarizes everything we were talking here today. Then if you want to go a little bit deeper, you know, in that part, how I do blah, 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 go and check this book. It's written by Adam Nathan, our test lead, and it's really great. It has 1,800 pages, but it's really worth, you don't need to read everything, just parts that you're kind of working on. And then MDAs, I mentioned, if you go to this, Adam has a blog, Adam Nathan has a blog, you can find lots about MDAs, and he wrote a great tool called CLR Spy. You can use with nice interface. Instead of kind of writing these config files manually in Notepad, you take a tool and just click on a couple of checkboxes, and it's great. And then there are a couple of blogs you would like to, probably want to check from time to time. CLR Interop team has an internal website, so if you go there, he'll be able also to find some interesting resources. And the names of people, you can send questions, which is also important. Some names are here, but you can find more names on the website. So that's it. Any questions now? Yes?
I'm using Interop in one of our applications. We had a managed code, and the DLL also is written with some functionality. That DLL exposes a function, which actually returns a string.
Okay.
And the allocation of that string happens inside the managed code.
Okay.
And I put a pinvoke wrapper around it. Try to call that. So what happened was I just passed normal string without parameter, assuming that the managed code will automatically DLL the string. And after using like 5 times 6 times in a loop, we started crashing. And someone could use ref. It won't crash. Use ref and it crashes. So what is the difference between log and ref? And even that's a top solution. After that, we discussed a lot, and we finally thought we should use NPTR instead.
Yeah.
And
Okay. So question was, when you are calling some p invokes and on a native side, in this case, string was allocated, how do you make a p invoke call that works? Do you pass a managed object to this parameter and hope Interop will just deal with memory correctly? What are the ways to deal with this? Short answer is you have to know what the contract the native code is having towards its callers. So who is responsible for allocating memory and who is responsible for cleaning memory afterwards. So if a contract is, well, you know, if you call me, I will allocate this string and I'll give you pointer back. You obviously can't call with passing a string as parameter because interop marshal will say, I have to take this managed string, it's allocated here, and I need to copy this maybe to NC, so I need to allocate a different memory and copy everything and then pass a pointer to this method. And that this method doesn't do anything with it or maybe crashes if you pass it something that's not empty. So again, depends on the contract and on the rules that interop marshaller has. So in the case like this, when a native method will allocate the thing by itself, you know, what you need to do is then, instead of declaring as string, declare as int pointer, because then interop marshal says, well, this is some pointer, I don't have anything to do with it, and you know, you deal with it. So then you pass a pointer, know when you get back, you will get a pointer to string. So there's, again, in marshal class, method that says, oh, you know, convert this to managed string and do marshalling manually. And sorry, so just one other thing is that you need to also know at any time, not only in managed native interaction, but in native code as well, that the way that memory is allocated, the same kind of the reverse API needs to call to clean the memory. So you can't, you know, allocate using this allocator and then free using some other deallocator, obviously. So a managed interop marshaller actually assumes certain allocations. So for example, a default is co-task mem alloc, co-task mem free, which is, you know, maybe not something that's you would expect. If it's B strings, for example, oh, okay, we know how to deal with B strings, so we know how to allocate, deallocate those. So you have to kind of think about that if it's at least, you know, a little bit complicated managed native interaction, and if it involves like strange maybe memory allocations. Can we maybe take that like after the, just to give a gentleman, because you know I'd have to kind of really understand your API. Okay. So question was why not use a string builder? And yeah, so it depends really. You know, you may be using string builder. How string builder works is that we will allocate the buffer and then we'll call native APIs, and then native APIs can write into this buffer and you will get result back, and that's okay. But sometimes you have maybe pointer to the pointer to string. You know, string builder then can't be that because string builder is a pointer to string. So you know, you have to know how many levels of indirection your API expects in order to call it correctly. You know, if it's pointer to string, well, then you have to declare it as ref int pointer because that's the only way to express two levels of indirection. So I'd have to kind of really understand what the API is before I can say what's really the best way to do this. But any other questions, because we are now close to, no, yeah? Oh, yes, there's, oh, sorry. Go ahead. Okay. Yes. So question was, is there a way to fine-tune interop marshallers to marshal only in one direction if that's a semantic of your API? And answer is yes. Interop marshaller has certain defaults. So sometimes it will marshal to the native and then back to managed. And maybe that's not behavior you need. Maybe you just need back or just marshaling to the native. And there are attributes in Interop services namespace. They call in attribute and out attribute you can use to give a hint to marshaller what needs to happen. Yeah. So yes. Uh-huh. Okay.
To pin the buffer, allocated buffer.
Yes.
How do we manage that using
So the question was sometimes buffer of memory needs to be passed to native APIs that expect that, and they need to be able to write into this memory. And question is, do I need to allocate this buffer and then pin it? And what's the correct way to deal with situations like that? So there's two ways you can do with this. You can allocate a memory, manage memory, like array, for example. If that's what your native API expects, pin this memory and pass this to a native call to avoid marshaling these arrays if you know that it's only integers, maybe. Even though Interop marshaller would know that, oh, this guy is the same as in native version, I just can pin it. So sometimes this is what will happen. Interop marshaller will pin these things for you. The other approach you can take is to actually use, again, magic methods from a marshal class to allocate buffer directly on a native heap. You can do that from a marshal class. So you can allocate a buffer directly on a native heap and pass pointer to this buffer to your pinvoke call, and this will work. So you have a couple of options depending, what's kind of the best thing for you. Yep, and obviously if you can allocate the buffer on a native heap, you don't need to pin it. Everything is pinned there. So I think that would be all questions. I can just talk with you offline, but thank you very much for coming so early.